Okay, good evening, and we are live on Facebook, LinkedIn, and Twitter as well, along with Run the World. Good evening, everybody. Thank you so much for being part of this wonderful session, and thank you, Venkat, for sparing time in spite of the. Okay, good evening to everybody. Thank you so much for being here and for this wonderful session. And we are also live on Facebook, Twitter, and LinkedIn. In fact, we've been planning this session for close to a month or 4 to 6 weeks, but we've not been able to do that for some reason or the other. We've not been able to. Finally, today is the D-Day. In fact, before we start, Venkat and I are part of the Ideas2IT Technologies company. We are a very high-end product engineering company based in the US, Mexico, and in India. And Venkat and I, we belong to the cloud data warehousing practice. We work on projects on Snowflake, Redshift, and other cloud data warehousing solutions. And we have clients across the globe, primarily in the US, where we work a lot on healthcare-related data solutions, be it AI, ML, or data science solutions for companies in the US. And very recently, we also tied up with a government agency to manage citizen data of a very important function. We're very likely to go public on that, but at this moment, it's in the final stages. So we've been building teams on cloud data warehousing, and I mean, as with any other IT organization, we are ambitiously growing, and we thought that instead of we were looking at how to grow the career or career progression of a person who wanted to work with data. And I don't have to appraise you about how important data is in the current world. Data is the new oil, and everybody there's a lot of things that is being used, done with data, and there's plenty of opportunities. And I think Venkat would share some statistics, during the presentation in terms of how important data is and how you can build a great career, on data, and how interesting this career would be. And particularly somebody who's worked just on SQL, because SQL is extremely important for any techie who's just worked on a SQL. Do we have an opportunity, to move to cloud data warehousing? And that's what we would be discussing in this session and a series of sessions that we are planning. Maybe 6 to 8 sessions where we will try to teach you as to how you can get into cloud data warehousing and work with data architects like Venkat. I need to bring that in because, as I told you, he's working on very important projects, and I had to grab his time to do this session for people so that it's useful to everybody. I was just reading an article. I don't want to bore you with more details before I give it to Venkat, but I just wanted to share an article that I read a couple of days back, particularly about how to get a career in data. And there was one very important thing that really caught my eyes. It was the plethora of tools that is available on the data side. You really do not know what to study or where to start, how complex it has to be, or should I start simple, etc., etc. So unlike other tools which are pretty easy for you to say, what I learned mean stack or MERN stack, etc. You know where to start and where to end. Data there's lots that you can do with data. So there's on one side somebody talks about data analyst, data science, data warehousing, data engineer, data visualizer, and so on and so forth. So what is right for you, and where should you start, and where would you get into such project? Because you read about, you get trained on one particular product, and you come to the market and you see that that's been used very, very less. So we thought that being from the industry and being responsible for people to make sure that they take the right choices, we thought that we'll do this series of session so that people who want to move from SQL to cloud data warehousing, yes, you've not hit a glass ceiling just by working on SQL, because SQL is a foundation for anything to do with data and how you can just get going with a career in cloud data warehousing. So before I hand over the mic to Venkat, a couple of ground rules. Any question that you may have, please type it on the comment so that we can take it up with Venkat. And so please do mention all your questions very in detail, so that Venkat would be happy to answer. And in case you want to know more about Ideas2IT, just visit ideas2it.com. And if you want to have a career with Ideas2IT, ideas2it.com/careers, we'll be very happy to see if your skills and our needs align with each other. Okay, so Venkat is a senior data architect with Ideas2IT, and he's been involved in data warehousing projects in retail vertical and the healthcare as well. He's got more than 12 years of experience with and has worked with data, very very sexy data. If I have to call it as, with companies that we all dream to work for. That's a kind of projects that he's worked in, and he's got vast experience, which he's going to share in the next 4 to 6 sessions. And today he will be primarily talking about cloud data warehousing, how a SQL developer can get an opportunity to become a cloud data warehousing engineer, and what is the kind of stream that we have in terms of the products that you can work on if you are part of Ideas2IT. Okay, thank you so much, and without much ado, Venkat, over to you. Thank you so much for being here, and I'm sure we already have 25 people around the world, and we are also live on LinkedIn and Twitter as well. So the stage is all yours, please.
Thanks, Venki. Thanks for this opportunity. I'm glad I could do this. So, everyone, hi. How are you? Hope everyone's doing well, safe and sound. Must be late in the evening for a lot of people after a long days of work. But I'm so happy all of you are here, and hope I can help you out. So the way we are going to go about this is, I know everyone wants to go for the golden ticket, wherein you want me to give you cheat tips basically on what needs to be done. But let's start with why everyone is talking about cloud data warehousing. What is it, and what way it's better? So let's just spend some time on that, and then at the end I'll probably start on giving you some ways in which you can proceed to continue on this. And then, since it's a series of talks, we'll go into detail further down the line on specific strategies, specific tools, or how to go about it and all of that. So let's get started. All right. So like I said, what's a data warehouse and why do people actually need it? So let's take probably an example of a retailer. Since I've worked a lot in retail, most of my examples are lean towards that. So let's take a retailer, and then there is a salesperson or a sourcing person. The sourcing person is nothing but who talks to suppliers and orders for more stuff for the retail. Okay, so the sourcing supplier has to know what's currently left in the company, how is the sale going, because he doesn't want to order something which is already there, or he doesn't want to order something which got sold off in a sale or something where they just pushed it out forcefully, right? So which means he needs to have access to the sales data. Also, he needs to have access to the inventory data, right? In pre-data warehouse world, how it used to work is they will have a system, they will go contact the inventory team, get the data from them, then they'll go to contact the sales team, put them all together in their own system and do analysis on top of that. Okay, just when I explained, you should understand this is just one team doing it. Imagine every vertical within the company doing this and creating their own bits and pieces of data, communicating with each and everyone to get regular feeds. It becomes a very huge hassle and nothing moves basically, and the data becomes incorrect very easily. So that's where your data warehouse comes in. It's nothing but a single integrated source of data from various sources, and it serves as a single source of truth. So I'll just rephrase that again. It's just an integrated single source of data from various sources, which can act as your source for your analytics, for your machine learning models, all of that stuff, visualizations, any of that. So so in this case, so going by the same example, so that the inventory team would publish their data to a data warehouse, the sales team will publish their data to data warehouse. All the sourcing team have to do is just connect to the data warehouse and view whatever they need to do. And this data would be integrated properly, which means it will be latest, get all the updated information, and it will also be a single source of truth. Okay. Now, important thing about a data warehouse is, though it holds all the information, it's usually never the master of any information. Okay. So like in this example, the master of the sales information is your sales database. So data warehouse gets a feed from that. So it's a integrator of all the data, but usually never the master of any of the data. Okay. So now that we have out of that picture, now what is a cloud data warehouse then? Nothing, just this available on the cloud as a service. Okay. So I'm guessing most of you are familiar with cloud. If not, we'll just quickly touch upon that as well. Cloud is nothing but a set of servers managed by a third party provider, either in a remote location or somewhere else, and we just purchase and use whatever set of servers we need from them for our own purposes. That's it. It's basically like instead of having your own house and setting up and building everything, just rent a hotel room. Removes all the hassle for you. So this data warehouse exists on a cloud in a distributed network, and you can just get that as a service and then use it. So that's basically your cloud data warehouse. But then why go for it? So I can do everything on. We have been doing it for a long time in our traditional systems, right? We have our own SQL server, MySQL servers, in which we have been pulling data, running reports. So why can't we continue with that? Why do we actually have to go for cloud or any of that? Simple. Let's say we have one set of data and we are running something, and suddenly, just give me a moment. Sorry. Yeah. And suddenly we get a huge spike of data. Okay. Or there is a new data requirement coming in. Let's say we have acquired a new company. So all that company's data has to now come in. Now, in a traditional world, this is first the business team would raise this requirement to the IT team. IT team would approve it. Then it will go to your infrastructure team, who will go and procure the larger server. Then they will install it, install all the packages on it, upgrade it, and then it becomes available with a huge lead time. And the older server becomes no longer useful to you as well. So it's a huge upfront cost because you need to purchase that whole server, and it becomes really difficult to actually increase it. So now you acquire it, and then you realize the company doesn't have a lot of data, but then you did acquire a large server. There's no other way. You have to live with it. So that's the issue, some of the problems, right? So that's where your scalability, elasticity comes in, and the cost comes in. Okay, in a cloud, I decide today I want to do, tomorrow I just register for an Amazon account and actually create an instance of Redshift with the server configuration I need, and I can load the data directly into that and start using it. That's it. Within a matter of minutes, I can actually have my data warehouse ready to actually query the data and just understand it. As simple as that. Okay, and it's also easy to like scale up and scale down. So let's say I have a data scientist who wants to like query the data. He wants to run like huge analytical queries, but I never know when they would use it. They can use it once in 2 weeks, once in a month, or suddenly use it on every day of a week, right? So these sort of unpredictable workloads in a traditional warehouse, then I need to procure a large server and just have it, which would be not be used most of the days, but on only certain days when the data scientist decides to use, if and they when they use it. So that's again a lot of cost is wasted. But in the case of cloud warehousing, data scientist gives a requirement that he needs to use, done, spin off, use it, and then again remove it off. That's it. You just pay what you use for, pay only for the time you use it for, and you can like expand and reduce your capabilities as much as you want in a minute's notice. And some of the data warehouse solutions actually provide that automatically. So they would be suspended whenever someone fires a huge query. They just become active, uh, do the processing, and then again suspend themselves. As cool as that. So that deals with the factors of the scalability and the elasticity, which is and then the quick to market. Like I said, within a matter of minutes, I can actually spin off and start using it. And if it doesn't work out, I can again remove it off. So there is no like legacy stuck with me or something, right? I can easily scale down and then just delete those instances. Cost and then the maintenance. So this is the factor I was coming in early, right? So if you have an on-prem service, number one, you just have to run those servers. You need to have a large team who maintain that, run upgrades, install the security patches, have it in a air-conditioned room with security to protect the servers and all of that stuff. In a cloud-based solution, all of that is taken care of by the cloud provider. You don't have any of that maintenance, manage, upgrade. All of those is taken care of. All you just plug and use it. That's it. The security is a double-edged sword. Though you can say on-prem. So the on-prem aspect is really good because you have whole control over it. You know where it exists. You know you have put the security people. You have CCTV cameras, all of that stuff. So you know you can sleep at night relieved that you know where it is, right? But in the case of cloud, you can probably decide which region or which provider uses it, but you cannot control exactly which server it sits on, or with along with which other data it sits on. So you have no control over that. But on the flip side, since cloud is this, the cloud data warehouse whole business model is this, right? So they would have the best security admins, some of the best security admins in the world sitting and doing. So the people you have may not know even all the latest like Lazarus leaks and all of that, but they would know all of that and patches would be in place to actually handle all of that. So that's why I said it's both a boon and a bane from the security standpoint. You'd have no control, and again, no customizations are possible, right? It's a cloud provider's SaaS offering, basically in most cases. So you have no flexibility or no customizations possible for from your perspective specifically, but on-prem you do have that. Um, so cloud has its own advantages. So, but it's not like a beautiful solution which solves everything. It has its own problems as well. But the good thing is your benefits far outweigh the cons. So that's why it's becoming a very popular one, and lots of people are looking at cloud data warehousing solutions and all of that stuff. Excuse me. So moving on, what's the industry trend? So as per a report by Forrester Wave, like I said, cloud actually ends up cutting to 20 to even in some cases like 80 to 100% of your data warehousing cost when compared to on-prem. So this higher level of cost would be for companies where there's like very irregular workloads and all of that stuff, wherein cloud would be like really cost saving. And due to all of this, what is currently an 18 billion US dollar industry is expected to like almost double in the next 3-4 years to a $30 billion industry. So that actually is pre-corona. So corona actually far increased the usage of code because of remote working and all of that stuff. So I'm sure it could already be far closer to that 30 billion US dollar cap. But that's the corona effect which has quickened the pace of that. So so then what can I do? Obviously, like when companies are investing so much, opportunities are opening up everywhere, right? But then everywhere you see that data science, data analysis, machine learning, MI, so there are lots of terms flying around. So what should I do as a beginner? Where do you start? Right? That's probably that's been a question even for me when I was initially starting off, like where do I start off and all that. Now it's actually become an even bigger problem because there are so many options out there, so many terms out there, right? So but then ultimately if you see, you have an artificial intelligence or you have an internet of things, you have machine learning models, all of it is actually going to run on some data. So it's not going to run on itself, right? So data forms the foundational bedrock of all of this. So if you have a machine learning model, in order to train it, you need to have a vast amount of cleansed data. So I mean, you don't cleanse it or you don't have proper data, it's only going to skew your results in a wrong way, right? So that's why even for that, it's a foundational thing. Internet of Things has a huge load of sensor data. All of it has to be like kept for you to monitor or action on it. So everything, the bedrock is again down to your data and probably data warehouse, because then you can use that for your other purposes, integrating systems. Like your prediction model says something, you need to immediately pass it on to your marketing team saying this is the trend, go and market accordingly and get us new clients, right? So everything has to be integrated. Now, one good thing is nearly 90% of it, I would say, is based out of SQL. So you know SQL, you're in a very good place, right? So that's a very good start. But from there, what I would recommend doing is probably start off with cloud. So it would help if you directly go to a cloud data warehousing, but it's always better to understand some basics of cloud, like what is scaling up, what is scaling down, what is on demand, what is reserved, and all of that stuff. So what is basically a S3 storage in AWS or a blob storage in Azure and all of it. So when I talk about cloud, don't worry whether AWS is the right thing or Azure is the right thing or GCP is the right thing. Don't worry about that. Just pick anything. Just pick one cloud service provider and then probably do a basic, either an Azure fundamentals or a AWS cloud basics. Just do that course so that when you deal with the cloud data warehousing next, some of those terms are not like very alien to you. Okay. So when you deal with your cloud data warehouse, it would just say multi-cluster warehouse, or it would just say scaling up your warehouse. But then your cloud basics course would help you understand what they are talking about when they say scale up, and then it would say this is your on-demand pricing, or this is your reserved instance pricing. So start off with cloud basics, and then probably pick one cloud data warehousing solution. Okay, my recommendation would probably be Snowflake, because the good thing with Snowflake, it gives for everyone. Just have an email ID, then just get a 1 month free edition of Snowflake. You can use it, play around with it, run queries, create tables. You can use up to like $400 of credits, which is a lot. Not easily used up. I'll probably recommend Snowflake, and you can probably pick a course on Snowflake basics, and then just work through the UI. Snowflake is anyway one of the hottest cloud data warehousing solutions in the market. But even if you think it's not the one thing and all that, that's still fine, because you get into one, you can easily relate and do the others. Okay, so if not Snowflake, choose Redshift. Only thing is probably for trying out, you might have to spin off a Redshift cluster, for which you might have to pay a little. Wouldn't be too expensive if you just do a very low configuration node. But that's where Snowflake is easy, right? Email ID, register, start working on it, create tables, understand everything, and even higher tiers of Snowflake can be taken in the free edition. So that's the advantage. So you don't have to. They only give the. It's not like they give only the base version. Okay, so don't directly go to the hot things in Snowflake like zero copy cloning or multi-cluster errors, which we'll deal with over the course of this series. So we'll touch upon in detail on Snowflake further. But then start with like creating tables, and then writing some queries, because the SQL, though it's underlying SQL, it will be slightly different. There will be like small variations. I'd say 90% would be the same, but small commands would be slightly different. The way you have dealt with partitions or indexes in your SQL database would be slightly different with clustering keys over here. Okay, so start off with that. Use your 1 month very effectively. The courses shouldn't. There are lots of courses on Udemy, YouTube, and even one provided for free by the Snowflake University itself. Okay, which fairly walks through every feature of Snowflake, from user management to your data management to your data maintenance, the key concepts of Snowpipe, zero copy cloning, and all of it. Okay, so that's where you can probably start. So once you look at the core data warehousing aspect of it, then it should be easier to expand into your ETL. So some of you, I'm sure, will be from a Informatica or ETL background. So again, that's again good in a way, because you would still know like the how data works, how do you load, what sort of things you check, what's the table, what things you need to take care when you insert, what's your upsert logic. You would have worked on stages and all that, right? So what yeah, start with cloud, pick Snowflake as a trial version, start doing it, or if not, go for Redshift. I'll probably stick to these two because there is a lot of helpful material on it as well to help you. Or if you are a huge fan of Azure, then yeah, definitely go with Azure SQL or your Synapse. Synapse would be better because it's more of a data warehousing solution. Azure SQL is just your MS SQL on cloud. Okay, and yeah, that's pretty much it. That's where I would start, and then over the series we'll start covering more in detail, and then add competencies to that. So, any questions? I just wanted to keep this short rather than like put in a lot of information to like scare you off the first session. So let's just keep it simple. I'm a very strong believer in the KISS principle. It actually means keep it simple, stupid. So basically, I am like that. So I just lean towards that. So any questions?
Yeah, I mean, if there are any questions, please feel free to type in the comments. But Venkat, I have a question.
Yes, ma'am.
I know that there are a lot of opportunity for data-related career, so on and so forth. But uh, are there any, I mean, from an attitude standpoint, is there something that is important for me to get into data, or so that I can enjoy this career? I just don't want to get into data because that's the latest in thing. But how do I know that I'm ready for a career in data?
Brilliant question, Nikki. I've seen my friends, lot of people like run behind the fad of data science, and then within a month they are like so frustrated in their jobs because they never liked it. They just ran because it was a fad. So that's actually a very good question, Nikki. So yes, how do you know you like data? Through experience, sort of. But then a lot of people here would have worked on data by now, they would have realized, so you need to have a knack of like being able to see through a lot of data but actually understand that it's ultimately giving me a small thing as an output of that. So I can see, because you need to understand that knack. So if you are like very fed up of doing some meticulous work and then iterative work and all that, probably not very suited, because data is a field wherein it's not like a switch, you put on something it works. So you need to start off with even a simple data analysis on a table to identify. Let's say I run a query, it's not running within 10 seconds. Okay, so I need to now sit and understand. It's not going to be like, okay, flick a switch and it works. You need to probably be, it will be iterative. So you'll first do this, then do that, do go step by step. So probably from an attitude standpoint, it needs a little bit of eye for detail and bit of an eye for detail is very important. So because you will be just bombarded with a lot of things, like you can easily have tables. So I have actually even worked on tables which are like petabytes of data, but then the end result they wanted from it was one number: what's my revenue from all those transactions.
Mm.
They wanted one number from a petabyte data table. So but then you need to have that eye for detail, the meticulous nature of it. Else it becomes a little difficult, because sometimes it feels a little dry if you don't have that.
Fantastic. Okay. I think we can stop sharing the screen. I have a question from Tejas. Tejas is asking, someone who is from a non-IT background is it possible to start their career in data science? And probably, I think, they, is it possible for them to move to data science? That's a
Yes.
question.
Yeah, definitely. So, from a data science standpoint, probably key factors would be actually mathematics, and mathematics actually plays a very key part. It's a little underrated from a data science standpoint, but actually mathematics plays a key part. Statistics, probabilities, and all of that stuff, and a bit of
Okay.
business knowledge is also needed because you need to understand the context of data. So non-IT background people, that would actually be an advantage because they will come from they would have worked either in the fintech or they would have worked in warehouses. They would actually come with a business background. But I'll probably start off with mathematics and SQL. So don't worry, the machine learning developers would talk about your Python code, your TensorFlow, your Dakai2, your SageMaker, and all of it. So don't get like they just that's probably for you. So don't get like bombarded or like intimidated by all of this. Underlying, it's basically you need to understand what the models do. It's at the end of the day equations in most of the cases. So if
Okay.
it's a classification model, or it is going to be an equation at the end of the day. So probably SQL would probably be definitely be needed. So from a non-IT background, that's something you might have to work on a bit. So SQL, mathematics, and business knowledge would be a very good start, and then you can start using your Python or any of that to run your analytics, or on top of that to analyze the data.
Okay. I mean, this is fantastic question from Karthik Ratnam. In fact, I've been trying to get answers for this, but these, tech people have not answered me so well for this question. But I'm taking this opportunity, and you are live, being watched by so many people. Now, let me see if I can get at least understand it now. So, Karthik Ratnam is asking, is database and data warehouse the same thing?
Yeah, it's a very common question. Add to that probably data lake as well. Data lake, database, data warehouse, data mart. So you talk so many things about data. Are they all the same and all that? Yeah. So there is a slight difference. A database is more of a transactional system. Okay. So let's say I have a portal, basically a portal wherein I go and register my details. Okay, so register my details, view my details. Okay, so underlying, as and when I type my details and click a save, it's going into a transaction system, and then when I want to view it, it's going to pull from that. So database is basically a transactional system which is for as an operational system behind your applications, or an application database. Okay, but your data warehouse is more aligned towards your analytical purposes and not a transactional purpose. Okay, so that's why a database is expected to handle like huge number of inserts, deletes, but it's not expected to handle a huge query, a huge analytical query, or churning through a lot of data. But your data warehouse, on the other hand, is actually a OLAP, basically online analytical processing. So it's more key towards your reporting, dashboarding, visualizations, and all of that stuff. Trend analysis.
Got it.
Did that help Venki and Karthik?
Yeah, okay. I mean, Karthik has got a follow-up question. He
Okay,
says
analytical.
analytical means. So,
Okay, sure. Analytical means like, okay, let's say we have a sales data. Okay, so it's, in shop we buy something, they generate the bill, everything goes and sits into a sales database. Okay, now I want to understand how my sales is growing for the last 12 months, how it's growing compared to the same time last year. What's the trend? Is it growing? It's going down, and what products are selling well? Which of my stores are doing well? All of this is your analytical reporting. Okay, basically looking at a whole bunch of data to identify your trends, and then seeing where it goes, all of that. Your operational reporting, on the other hand, will be like how many transactions did they happen today? What is the average time taken for each transaction today? How many records did I process in the last 2 hours? So these sort of measures or some things will be your operational reports, but your analytical reports would be like trend analysis, your data mining, all of that stuff.
Fantastic. So Swati's got a question. I believe you kind of answered this, but then maybe let's make it a little specific. What are the key skills which are required for fresher to enter and to take up a database role?
Okay. So as a fresher, SQL. So at the end of the day, wherever, whichever role, whether you're going for data analysis, data warehousing specialist, data engineer, everywhere probably SQL is a key part. Okay. So start off with SQL. Understand some basic data warehousing concepts or basic data concepts per se, not necessarily data warehousing concept.
Got it.
So like what's a partitioning, what is an indexing, what is a distributed storage or distributed, and even distributed can be. Probably start off with like what is partitioning, what is indexing, how it helps to improve your performance, all of that stuff. So understand, and then what is a fact table, what is a dimension table, what is a change data capture. So start off normalization, denormalization. So start off with some basic data warehousing concepts and SQL, and then from that, either we can specialize in a data warehousing solution per se, like a Snowflake or a Redshift, like become a data warehousing engineer, developer, or a specialist who writes a lot of stored procs, does the administration for that, or you can be an ETL, then move on to a ETL tool like Informatica, or if you are going for a cloud-based one like Glue, learn a bit of Python or something to do your engineering work. Engineering work is nothing but bring your data from source, different sources into your warehouse, or from your warehouse to somewhere else if you want to like take the data and all of that stuff. So engineering, core data work, or basically data analysis, wherein you just run queries to find patterns in the data and all of that stuff. So start off with SQL, learn a bit about data warehousing concepts, and then go for a programming language like Scala or Python, which will help a lot in data engineering.
Fantastic. So Vishal has got a question. I think I can take that, because it doesn't seem to be a technical question. If a person knows about AWS and DevOps was a gap for 3 years, can the person enter into cloud jobs? I think definitely, Vishal, we can. Rather, that person can get into cloud jobs. Probably initially they may have to make some sacrifices because that will be a learning experience, to bridge the gap, or probably to learn, and post which they can build a career on it. Long story short, yes, they can get into cloud jobs. Chandni Gowda is asking, what are the career opportunities in data science?
Everywhere,
Yeah,
wherever you look, everywhere. Everyone is now behind data science, right? So it could be as simple as predicting the weather, or predicting the COVID spread, or
yes.
predicting the impact of climate change on the world. So wherever you look, there is prediction, understanding patterns. So there's a lot of data everywhere. So many systems are now digitized, so many sensors everywhere, but no one knows how to use it, how to derive useful information from that, and everyone is looking for it. So, so yeah, a
Yeah,
short
I mean,
answer, everywhere.
yeah, I think I want to share a very interesting, project that we worked on. We did a project for, driver behavior in electric vehicles, and because in India, electric vehicles is still not really become popular for the lack of, say, charging stations, etc. So we built a tool, rather we built a solution with data, and based on the driver behavior, where a car is likely to get, likely drain its battery capacity, so that you need a charger, and that's a That's a very interesting data science project that we did, and a few more that we did as well. So almost in everything, data science has become extremely important. So Chandani's got a follow-up question: how does data science add value to the company?
Okay. Um, Again, from my experience, let's go to a retail. Okay. So I have a lot of data which says this product got lost here, or when I know it was lost, so I know what was happening in that case, who was working there, and all that. A simple data science solution would be writing a prediction algorithm to look at all these factors and actually predict when this person is in this ship. Okay, let's not go to a person. So let's say when a product is in this area of the warehouse at this point of time, it actually gets stolen a lot. So if you find that, you can actually this actually a live example I worked on. So I'm not just quoting some hypothetical situation. This something I worked on. So we actually derived that, and then the company actually realized huge savings. So they were actually storing their iPhones there. So post this, they actually realized they need to put a security guard there, and eventually moved that to a different place, which had like a better lighting and better security pattern and a CCTV camera present. So the corner where it was getting lost did not have a CCTV person. So this is where you derive based on it and find patterns. Okay.
Yeah, and very interestingly, in fact, I think Uber and Ola are companies which use data science quite a lot. And I mean, imagine they having a lot of cars and assigning 10 each to various regions, etc. It will not help because mornings there will be a lot of takeoffs, departure happening from the airport. So there's no point in having cars there. But whereas late in the evening there will be a lot of arrivals. So what they're using data science, I believe, they will figure out where is the maximum traffic at what time, and they make sure that more cars are in that region. So I think it's more about predicting how you can maximize your resources and also get the best out of it. Because imagine, I mean, take the example of Uber or Ola. If they have 100 cars and they put in 10 different places, and if there is the bigger demand in one area and there is no demand in another area, you are losing it out. Rather, it's wiser for us to make sure that they are in the right place at the right time. I think these kind of uh, analysis and insights are what you get out of data science, etc. Uh, Karthik has asked, data warehouse included for AR or VR? Did I understood this question right? I mean,
I think
is
he's talking.
AR part of data warehouse? Is that a question?
I'm guessing yes,
Okay, maybe Karthik, you can explain that question a little more because we don't want to misunderstand the question. Uh, Vishal is asking, what is the difference between Python and data science?
Okay. So Python is your programming language. So you can actually use it to do what you want. So you can write an application to bring data from Twitter, or you can write a custom application to actually report your data, or you can actually build a pipeline using Python. So Python, you can do anything using Python. Data science is a field in data wherein you try to mine and either predict or identify patterns from the data, which can then put used for to derive business benefits or cost benefits from that.
Okay. Thank you, Tejas and Sumit, for answering that question.
Oh yeah, thank you.
Asked by Akshay. I think both of you are right. So thank you so much. And sorry, that question was from Vishal. Akshay has got a question. How deep a fresher should learn a programming language in SQL to enter database roles?
Okay,
So I probably, Venkat, I'll add a common sense answer. Then you can probably give a technical answer to it.
sure.
So there is, I don't think there is any scale because I have team members in my team who've been SQL developers for 6 years or 7 years or so many years, and they still are learning SQL. So I don't think, I mean, like with any other programming language, I don't think you can master anything completely. So you need to keep learning, and the more you learn, the better the opportunity is for you to get into a database role, rather than just being superficial and knowing what the SQL commands are, etc. I think you need to get into using this in a live project. I mean, not live project, at least, because the data sets are freely available. You can get data. I mean, large data sets are available freely, publicly on the internet. You can use that and do your own mincing and slicing and dicing, and keep exploring that. I don't think. I mean, there is any straightforward answer in terms of saying that learn 10% or 20% or so. So I think you need to just keep learning, and even at Ideas to IT, our developers are architects. Like somebody who's like Venkat, who's been architecting, who's a data architect, architecting a lot of data solutions, still keeps learning, and
Yes.
even at the SQL level, forget about on cloud, etc. Because most of the data warehouse tools, I mean, I'm not sure about others, but at least Snowflake works with ANSYS SQL. So it's very important for you to get the foundation right. It's like, the foundation. So, Venkat, is that right? Or you want to
Yes,
give a
Venki.
better answer than
So,
this?
yeah, actually, the answer to it is actually more common sense, because any syntax Google can give you. You don't have to have everything in your mind, as long as you know what you are searching for, right? Uh,
True.
so, so I'll probably a good start probably in SQL. Better to know like all your DDLs, like how to go about creating tables and all that, and then join tables, like some basics like partitions or something, and then continue learning and build on top of it. So be comfortable writing certain functions like sum, count, order, group by, all of that stuff, and then start from there. From a Python standpoint or any programming language standpoint, be familiar with basically variable assignments, operators, and then like storing them into objects and retrieving them, and all of that stuff. So
Fantastic.
programming is slightly different, difficult to say, because the programming has different levels for different requirements. But at least from a SQL standpoint, I would recommend, don't look for some predetermined level. Rather, ensure you cover the basics and then keep learning on a daily basis by working on it. So theoretically, rather than watching a video, it would be better to actually, like Venki said, pick some data set, run queries on it, try to pick a column and then find the total, do stuff like that.
Okay. So, Santosh has got a question. Is master data management a part of data warehouse?
Mm, partially, but theoretically it's actually a separate concept. So your master data management is your system which you use to maintain, and it's a source for all your master data. So by master data you can say, like, your a list of stores, list of cities, or the list of products which you sell in your store. All of this is your master data, right? So each of the products will have attributes like what is the height of the product, what is the weight of the product, what is the color of the product, and all of that stuff. So that's your master data system. In many cases it's actually either rolled into your ERP or having its own cases. In some very small enterprises it's leveraged sometimes, but not probably very recommended. So master data management is definitely not your data warehouse. Theoretically, both are like very different concepts. Technically, you can sometimes leverage it. It's not the system won't support it or something. But the whole purpose and the theoretical definitions are like completely different for both.
Fantastic. Okay, the next question. Okay, thank you, Sumit, for the
Thanks, Sumit.
feedback. And Kiran has got a question. How modern data sharing delivers even deeper insights?
Okay. Um, So let's say, again, going for retailers, beating the same bush. Uh, uh, let's say I am Reliance, Big Bazaar, Star Bazaar, and then Sarvana stores maybe. Okay. Now, all three are competitors. They have their own data. But there could be some broader market industry trends. Maybe you can notice that even though is for a different segment of customer, like the person who shops in Sarvana stores is not the same one who probably shops in lifestyle or something. Okay. There could be slight overlaps, but in most cases it's not the same, right? But then you could notice that both of those people are still buying shots. Okay. Which will help in a modern data sharing system. That's actually a business model for some companies wherein they collect data from all these people and then give the whole data back to those people. So let's say I am Saravana Stores, I will share my data, and in return, I will get the data for lifestyle, pantaloons, Big Bazaar, all of it. Of course, sensitive data will be taken off, but that would help to understand industry level trends and where the market is going, whether the customers have changed, all of that stuff. So that's where your data sharing, the more you make it ease, the more it contributes to the development of the whole, rather than competing against it. So understanding this as a whole will help all of them, because then they can actually go ahead and have more shots in their stores and sell more.
Okay, fantastic. I think we are done with all the questions. Okay, thank you, Tejas. One last question. Ideas trading currently have an opening. Data is related to your roles. Yes, Tejas, we do have quite a handful of opening in data-related roles, be it the data engineering team, be the visualization team, or the data warehousing team, and
Sorry.
also data science. We do have quite a handful of openings. You can definitely visit our website to know what are the openings that we have, and I think it's available. It's I'll share the link. That's it.com. So please visit ideas2it.com, and you can go to the career site to know what position that we have. Okay, I think okay, we plan to have a shorter session because we wanted to have continuous ones. But thank you for the overwhelming response. I think we'll take one last question from Akshay. What are the best practices for a fresher to nurture themselves on daily basis? Practice,
Consistent,
practice, practice.
consistent practice. So
Yeah,
just
I
keep
think
in touch.
consistency matters. So, try to spend a lot of time. As I told you, there are data sets that are available, and then, work on it, be consistent, um, practice every day. I think that's where your answer is in the question itself.
And
Venkat.
also like learn from other people as well, like uh, look at forums, understand what sort of problems people have already faced and resolved, because we don't have enough time in our lives to actually learn only from our mistakes. We need to learn from others mistakes as well, so that we don't repeat it and save some time for ourselves.
Okay, so Albin has asked a question. Any platform you suggest for getting exposed to Snowflake? So I probably understood it as you want to learn Snowflake. I think Udemy has got a couple of interesting courses, and Snowflake.com itself has got quite a lot of core materials that is available, plenty of materials. And I believe, if I'm not wrong, you also get a trial edition of Snowflake where you can play around with the Snowflake environment itself.
Yes, Vicky, for a month or $400 of credit, whichever is early.
Yeah, which is good enough for you to play around with Snowflake. And
$400 is like very difficult to actually use up. So you need to put in extra effort to use that up. So it's more than
oh,
enough.
Fantastic. I think that ends our session. Thank you so much for patiently being there. I'm so glad people being present throughout the session. And this is first of the many sessions that we'll be doing, but it'll be on data related, data engineering, data warehousing, and probably data science as well. Some would be a highly technical session in terms of getting my team members to share some of the knowledge uh, in terms of nuances while doing practical projects, etc. So I'm hoping that you'll give the same kind of response for our subsequent sessions as well. In case you've not registered, please register again so that we have your email IDs and keep you notified on the various topics that we have. Okay, thank you so much. I'm stopping the stream now. In case somebody wants to come to the stage and have a chat with us, we'll be available for the next 5 minutes. Thank you so much. Hey, thank you, Venkat. Thanks for the time. And though I've been hearing you every day, I think it was very interesting for me to hear you one more time. And I'm sure that it's the same thing with all the participants as well, because they've all been glued to the session right from the beginning till the end. I don't think we've lost anybody, during the session. Thank you.
Thanks a lot, Venki. This was a great opportunity for me as well.
Bye.
I was happy to do it.
Yeah.